Dear friends, in the last week, last lecture, we studied how bandwidth and stability increases due to application of the negative feedback. And today we are going to consider how distortion noise levels are reduced due to application of the negative feedback in the amplifier. Friends, the negative feedback is advantageous to say that there is a decrease in distortion. Any type of distortion, maybe it is a phase distortion, maybe it is a frequency distortion, or maybe it is an amplitude distortion. All these distortions are going to be reduced if we apply the negative feedback in the amplifier. The same we are going to prove it here. Let me first define the meaning of distortion. Distortion is nothing but deviation of the input signal which is present in the output. So output signal is deviated from the input signal. That deviation generated at the output is, we can call it as, it is a distortion. And such a type of the distortion is less when you apply the negative feedback. This deviation may be in the form of the phase of the input and output signal. This deviation may be in the form of the frequency. This deviation may be in the form of amplitude. All these aspects are togetherly, we can call it as the distortion. And this deviation, if present in the output, then that deviation of the output signal from the input signal is, we can call it as the distortion. Such a type of the deviation is totally reduced when we apply the negative feedback in the amplifier. Friends, to prove that, let me consider the block diagram of the amplifier and the feedback network. Here, this particular block represents the basic amplifier whose voltage gain is A. And the lower block represents the feedback network representing the feedback factor as a K. The input signal is applied for the purpose of amplification. The signal is amplified by the basic amplifier by the gain times, that is A times, and that is made available at the output. Some part of that, it is a feedback, and then by utilizing the feedback network, the part of that output, it is given back to the input. Same concept is used, but now here we are discussing only about the feedback associated in the form of the distortion. Let me consider capital A be the gain of the basic amplifier and D be the distortion present in the basic amplifier without feedback. And let me consider AF be the gain of amplifier after feedback and DF be the distortion in basic amplifier at the output of the basic amplifier after feedback. After feedback, K times DF is the feedback which is provided to the input. So KDF is the distorted feedback added with the reverse polarity to original distortion D. D is a distortion without feedback, DF is a distortion after feedback, K into DF is the feedback distorted and it is added into the original distortion with the reverse polarity, means it is subtracted from that of the original distortion to make the net distortion as a DF. Means when you subtract KDF from original distortion D, we will get the net distortion as a DF. So that's why we can write about DF as DF is equal to D minus K into A into DF, where K is the feedback factor, A is the gain of basic amplifier without feedback, DF is the distortion after feedback. So K into A into DF is the amplified feedback signal. If it is subtracted from the original distortion, we can get the net distortion after feedback. Just manipulate the terms, transfer K into ADF to the left side, so that we can get DF plus K into DF equal to capital D. Take DF common, DF into bracket 1 plus K, and that's equal to D. Therefore, DF equal to D upon 1 plus K into A. Friends, here denominator is greater than 1 because K times gain times the feedback factor is added into 1. So denominator is more, and that's why the value of DF is less. Thus we can say DF is less than D, and we are aware that DF is a distortion after feedback, and this distortion after feedback is less than the distortion before feedback, that is capital D. Thus we can say the distorted feedback is feed in opposite direction to compensate the original distortion and try to make less distorted output. Thus, after negative feedback, the distortion decreases. This is how we can prove that there is a decrease in distortion after application of the negative feedback. So, analogous to this, negative feedback amplifier also decreases the noise. So, what is the noise then? Noise is unwanted signal which is present in the output, which is not present in the input. Noise is not expected at the output, but it is going to be present, which is not related to input. For example, if you are listening the radios, from the speaker, unwanted sound that appears, that is called as noise. On the television screen, in most of the time, a white dots are going to be appearing. It is called as a noise. On the television screen, picture behind picture is produced. It is called as noise. On the television screen, there is a phase lag is going to be generated between sound produced and that of the motion of the lips of the person who is speaking. It is called as a noise. If you are listening the radios, suppose someone is starting the vehicle, the spark arc which is generated in the spark of that particular vehicle will be picked up by the antenna of television or antenna of radio, which is not a part of the signal, but it is appearing from the speaker. It is called as a noise. Thus, all these are the very good examples of the noise. So, such a type of the noises are going to be reduced if we apply the negative feedback in the amplifier. Noise is unwanted disturbance in an amplifier which is not derived from the or related to the input signal, but it is appearing in the output. Noise is of two types. One is the internal noise. Internal noise means noise which is generated due to the internal electronic components used, due to the heating the active devices, due to the heating the passive devices. Internal noises are going to be get generated. And second one is the external noise. Here the sources of noise are external to the amplifier design. Maybe it is a terrestrial noise, maybe it is atmospheric noise, maybe it is a man-made noise, maybe it is an industrial noise. So all those are the examples of the external noise. Hence we can say there are two types of the noises. One is the internal noise and second one is the external noise. Let A be the gain and capital N be the noise without feedback, and AF be the gain and NF be the noise after feedback. K into NF is the feedback noise added with the reverse polarity to the original noise N to make the net noise as a NF. So this is same as that of the aspects which are used in decrease in distortion. We just replaced D by N. Same block diagram we are considering here. Here also there is a basic amplifier with gain A. There is a feedback network with feedback factor K. NF represents the noise after feedback. It will be picked up, sampled by the sampling network and given to the feedback network. Feedback network converted into part of the feedback signal by multiplying it by K to develop K into NF as a feedback signal, and it is added back to the original noise, that is capital N, with the reverse polarity so as to get the net noise after feedback, which is given as NF is equal to N minus K into A into NF. K into NF is the feedback signal. It is amplified by the gain times so as to generate K into A into NF signal. If it is subtracted from the original noise, capital N, the resulting noise will be noise after feedback, that is NF. Transfer K into ANF to the left side, so it becomes positive. NF plus K into A into NF equal to capital N. Take NF common, so that NF into 1 plus Ka is equal to capital N. Therefore, NF is equal to N upon 1 plus Ka. Here also, Ka is added to the factor 1. So, denominator is more. So, NF is less. So, NF is less than N. That indicates that noise after feedback, after negative feedback, decreases than the noise before feedback. Thus, we can say the feedback noise is feed in opposite direction to compensate the original noise and try to make the output less noisy. Friends, this is how one can decrease the distortion and noise due to application of the negative feedback.